In this video, we're going to take a look at number 6 from the Practice Solving Triangle practice work from the CEMC website. So let's take a look at our triangle and let's see what we're asked to do. First of all, we are told that in triangle ABC, let's sketch that as we go, we have side lengths. A is equal to 6. So if this is A, this is 6, this is side A. B is equal to 7. So if this is corner B, side length of 7, side B. And we are told that C is equal to 5. So C, 5, side C. In this triangle, we are asked to find the area of triangle ABC. Round your answer to 1 decimal place. Now, we know that when we are working with a triangle, to find the area of a triangle, we need base times height over 2. I know the base of this triangle already is 6. We can see that clearly. What I don't know is the height. So I'm going to draw a line extending from the topmost part of the triangle, which is corner A, down to the base, and that's going to meet at a 90-degree angle. So what we need to do is figure out the height of this triangle and then use that information to solve for the area. So what I'm going to do first is look at triangle. I'm going to label this intersection point here D. I'm going to work with triangle ABD to start. So I'm going to sketch that. Triangle ABD. And I know this side length here is 5. I know I'm going to call this my height. And I'm going to label with my trigonometric notation. So I'm going to have my hypotenuse. My theta is going to be here. We're going to need to find that. My opposite and my adjacent. Let's think about what we know about this triangle. I know the hypotenuse. I want to find the opposite. So I'm going to use my sine law, or like my sine ratio. Sine theta equals O over H. Or sine theta equals O is height over 5. And so the height is equal to 5 times sine theta. I want to know my theta, but I don't know it yet. How can I find that? Well, I have a triangle where I know all the sides. I want to find one of the contained angles. That's my theta right here. So I can go ahead and use my cosine law. So using cosine law, angle B is equal to cosine inverse of C squared, so 5 squared, plus A squared, so plus 6 squared, minus my B squared, which is 7 squared, over 2AB, or 2 times 5 times 6. And if I go through and do that calculation, cosine inverse of 12 over 60, and we can reduce that, although I don't really need to, and that angle is going to be approximately equal to 78.5 degrees. So I know my angle there, my angle B, which is my angle theta, and now I can sub that in to my equation over here. So I can find that the height of this triangle is equal to 5 times sine of 78.5 degrees. Plug that in my calculator, 5 sine 78.5, and I have a length of 4.9 units. And we're not given units, so I don't have to write centimeters or anything, just the number. All right, let's go back to our original question. Find the area of the triangle, and I need base times height over 2. Well, I know my base length. It's right here along the bottom. So 6. I know my height is 4.9. I just found that. Over 2. And that's going to be approximately equal to 14.7. So therefore, the area of triangle ABC is approximately, well, I should use words. Let's go back. Is approximately 14.7, and I don't know the units, so I'm just going to say square units. As you will have noticed, my screen capture software stopped at this point in the video. Rather than re-recording this video, what I'm going to do is let the voice just keep playing, and I will show you an image of the completed note. I know it's not as good as following along step by step, but that's the most efficient option to fix this at this time. Now for question B and C, I'm going to use a similar method, but in more general terms. So let's go ahead and let's take a look at B. For question B, we are told for any acute triangle ABC, show that the area of triangle ABC is equal to half AC sine B. So generally speaking, I'm still looking for area of a triangle. So base times height over 2. I always recommend making a sketch anytime we're working with something with vectors or geometry or whatever. So I'll draw my sketch. My theta is here. Notice it's less than 90 degrees, so this is an acute triangle. I'm going to need the height, so I draw my 90-degree line going from the top to the bottom. And let's label our sides accordingly. Corner A, B, C. This intersection point here we're going to label D. And I'll label my sides, so small b, small c. And all the way across the bottom here is small a. Once again, I need base and height. I don't know the height yet, so I'm going to have to find it. So let's think about just our right angle triangle for a moment. B, A, and D, 90-degree angle. And I need to know theta. I don't even need to solve it in this case. I don't have numbers. I'm just solving in general terms, but let's label in terms of trig ratio, hypotenuse, opposite, and adjacent. And if I write out my rule, sine theta equals O over H. And this is my side C. And this is my side B. Then we see that sine theta is equal to opposite, which is my height, over hypotenuse, which is my C. Or in other words, if I rearrange, height is equal to C times sine theta. And I needed two parts for my formula here, the B and the H. I know the H now, it's C sine theta. And I know the base is just along the bottom here. My base is A, so base is equal to A. So let's write our formula. Area of my triangle is base, which is A, H, which is C sine theta, over 2, or if we write that, half AC sine theta. And what did the question ask us to determine? It said, for any acute triangle, show that the area of triangle ABC is equal to 1 over 2 AC sine B. And we just did that. I should change my label though. Just notice here that my theta is next to my vertex B. So theta represents angle B. So I can rewrite that one final time. Area of my triangle is 1 over 2 AC sine B. That's it for B. Now we're going to do something very similar for C. C tells us, for any oblique triangle ABC, show that the area of triangle ABC is equal to 1 over 2 AC sine beta, or sine B. So it's the exact same question as before, except now we're dealing with an oblique triangle. So our angle is going to be more than 90 degrees. So we're going to make a sketch real quick. Notice that angle is over 90 degrees now. That's my angle B, and I'll label that theta, side B, corner A, and side A, corner C, and side C. And I'm going to need the height, so I'm going to indicate that here, going straight down. 90 degrees there, and we'll call that point D, following the convention we used in our previous question. All right, so I need to figure out two things again, the base and the height. The base of this triangle is already given right here. It's length A, so the base is equal to A, and the height is what we're going to need to figure out. Well, let's take a look with our right angle triangle once again. I'm going to have triangle A, D, B. And I'm going to need to know my angle here, which I'm going to call beta. All right, let's add our missing label to our triangle here. I forgot. This is our height. Let's work with our right angle triangle and our missing angles and stuff to figure out how can we find that height. Let's label our triangle A, D, and B. This can be angle beta. This is our height, and this is side C. Notice that there is a relationship, which we can see right here, between angles beta and angle theta. They are supplementary. They add up to 180. So we can indicate right away that theta is equal to 180 minus beta. Let's take a look at our right angle triangle. Which sides are we working with? I am given, or I would theoretically know, the hypotenuse, so we're going to have that value. We are trying to find our hypotenuse, or sorry, our h value, our height, so that's my opposite, across from my angle, and adjacent goes down the bottom. So once again, we're working with sine theta equals O over h. What do we know about theta? Well, theta is equal to 180 minus angle beta in this case. The opposite side is our height, and our hypotenuse is side C. And so similarly to last time, we can define our hypotenuse, or our height. Height is equal to C times sine 180 minus beta. And what do we know about our sine value? Well, sine of 180 minus beta is the same as sine of beta. So let's take a look. If we drew our Cartesian plane really quick, if angle beta was here, sine is our height, so that would be this value right here. If we did 180 degrees and started here and rotated negative beta degrees, so beta degrees in the opposite direction, we would end up here. And that has the same sine value. It's the same height. So I can rewrite this, h equals c sine beta. Or in other words, this is also theta. So theta is the angle we're measuring up. Now we can simplify this a little bit. So we can actually see that, h is equal to c sine theta. How does that work? Let's take a look. If I have my axes, x and y, 180 degrees, so start in my initial position, rotate 180 degrees and go up. Beta degrees brings us here. Sine represents the y value at that point, so that is this value right here. Similarly, how do I define theta? Theta is measured from the starting position and rotating. So we're still describing the same angle here, and obviously the sine here will have the same value. So sine theta is equivalent to sine of 180 degrees minus angle beta. So now I have my height and my base. I can plug this into my equation. So area of my triangle is base times height over 2. The base has a value of a on my original triangle. The height has a value of c sine theta over 2. Or if we rewrite, 1 over 2 ac sine theta. And what was the actual question that we were asked to answer? It says, for any oblique triangle ABC, show that the area of triangle ABC is equal to 1 over 2 AC sine theta. And that is what we have. And once again, it's just a matter of labeling. Notice theta here is my angle B. So I will rewrite that one final time. Area of the triangle is equal to 1 over 2 AC sine of angle B.